Good afternoon, everyone. Today we have Lab 9, it's well log interpretation. In general, well logs are used to give an image of the rock formation while drilling the borehole. So well logs can be used to determine mineralogy, lithology, porosity, permeability, and the type of the liquids trapped in the formation. For example, oil versus water or oil versus gas. So there are different types of well logs, but in today's lab, we are going to focus on specific ones because you need these logs to answer your lab exercise. The first one is the gamma ray log. As we see, there's two value, high value and low value. Shale is always has the higher value in comparison with other rocks, and it's used the gamma ray log. It is used mainly to distinguish shale from other lithologies. As we see, shale has the higher value. Sandstone, limestone have the lower value. Why shale has a high value? Because of the radioactive minerals the shale has. As we see, you might have like shelly sand or siltstone, mudstone, and the gamma ray might be moderate because we have two lithologists mixed together, shale and sand. In this case, you might have a moderate value, which is between the high and low, as we see in this figure. So shale is always shale always has the higher value, and the high value of the gamma ray is to the right, the low value is to the left. The second type, it's density and neutrons logs. Neutron and density are used mainly to evaluate the porosity of the formation, and they can be affected by the neutron moderating characteristics and the density of the formation minerals. As we see in this figure, limestone has a coincidence density. Limestone has a coincidence density and a neutron response. Dolomite, on the other hand, have a relatively low density porosity because the grain density of the dolomite is higher than the calcite. So dolomite has low density porosity. What about the neutron? So the dolomite has a relatively high neutron readings because the neutron moderating characters of the dolomite is higher than the calcite. So let's make comparison between the dolomite and the limestone. Dolomite has low density porosity and high neutron readings. Limestone has a coincident density and neutron values, and the density is less than the density of the dolomite because of the grain, because of the calcite, the low density of calcite grains. Sandstone have a relatively high density porosity because the grains density of quartz is less than calcite. So sandstone has higher density porosity in comparison with dolomite and limestone. And sandstone has a relatively low neutron reading. Other type of logs is the resistivity log. Actually, the resistivity focus on the liquid trapped in the formation. And it's used mainly to measure the electrical resistivity of the medium. As we see in this section, we have gas, oil, and water. Gas and oil have high resistivity value, while water has lower resistivity value because water has high conductivity. So it will have low resistivity. So oil and gas have high resistivity value. Water has lower resistivity value. The last one is, it's called the photoelectrical log. In general, it's the read one. In general, it's focused on the mineralogy of the formation, because some minerals in evaporates like halite, gypsum, have elements, and these elements have high atomic number. So therefore, these minerals or rock will have high value because of the large atomic number of the minerals the formation or the mineral have. So it's the read one. As we see, it's high in halite and hydrite and gypsum, while it's lower or gives low value in shell rock. So when you go to the Blackboard and download the Oz Machine app and the 4 exercise 1, exercise 2, exercise 3, exercise 4, when you open the Oz Machine, you will see something like this. So these don't care about these because they are already downloaded to the software or to the app. So you have to download your own exercise, which are exercise 1, exercise 2, exercise 3, and exercise 4. What you need to do is that click read las. And go to the file that has your exercise 1, 2, 3, 4. I have them in my desktop. So go to the lab 9. Exercise 1. Okay. And it will be downloaded to your Oz Machine app. So we need to fill this column, the white one, and you have to choose your lithology from this section. So it's a gamma ray. So generally we use the gamma ray to distinguish shell from other lithology. So I told you the high value to the right, the low value to the left. So this is high value. Let's see, it might be shell. Let's take shell. Click shell and click here. So we think it's shell. To make sure if it's shell or not, or to make sure if our answer is correct or not, you have to do like check lithology. And if you see any red dot, like to the right or to the left, that means your answer is wrong. Let's see, it might be sandstone. Let's click on sandstone. I click sandstone here. We see like red dot, which means our answer is wrong. So we have to pick shell. And this is right. So you have to do like what I did. Make sure the check lithology box is on. So if there's any wrong answer or wrong interpretation, you will see red dots to the left of this column. So you have to pick another or different lithology. So you have 4 exercise. Make sure to download the Oz Machine app from the Blackboard and download the 4 exercises. And when you finish from, for example, exercise 1, you have to take a screenshot of this image and save it to your computer, and then you can do read las and upload exercise 2 to this software and work on exercise 2. When you finish with exercise 2, take a screenshot and save it to your computer, and so on. Please, if you have any question, feel free to ask us. So try to check the lab lecture as soon as it's uploaded to the Blackboard. So if you have any question, you have time to ask before the deadline of this lab.